So we're on page 12.
This is going to be hard to remember.
Your review is pages 12, 13, 14, 15. Let me show you what we're going to cross out on that. The quiz will have these blanks up here. Let's remind ourselves what goes in those blanks without trying to look at that board. First one, Beck, give me the first one.
Sine squared x plus cosine squared x, or times, sorry.
Plus.
Plus equals 1.
Perfect.
And then divide sorry.
It's okay, divide by.
That equation by sine or cosine.
Let's do sine squared on the first one, then you're going to do it for me. What is sine squared over sine squared? Good. And cosine squared over sine squared?
Cotangent.
Squared. Equals 1 over sine squared?
No, sorry, that's going to be
cosecant. Cosecant, very good.
X, and the other one's just the opposite. It's going to be
When we divide through by, cosine squared.
X equals secant squared x.
Okay, dividing through by cosine squared right here would get me that tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. Let's do it. What is cosecant? 1 over?
1 over sine.
Yep. Secant? Cotangent? Cosine over sine or 1 over? Nice.
And then tangent is just sine over cosine.
Yep.
Sorry, Jesus, 1 over cotangent.
You got it.
Okay.
So I'll put my answers for just these first two. On these first two, I got 1 for this one, and I got sine for this one. Everything else, I'm not going to put my answer up because, boom, you know what they have to equal. The time is yours. We'll have a formative on this on Monday. Quiz the second half of block day. So when we've got this, could we condense those tops?
Yes.
So we'd have,
Cosine squared over sine.
yeah. Are you okay with that, Wilson?
Yeah.
Okay.
So you don't cross multiply?
Well, you can only cross multiply, bud, when you have an equal sign in between two fractions. So when you just have, when you're multiplying, you always multiply just straight across. When you've got common denominators now,
It's just 1 minus cosine.
1 minus cosine squared would be on top. What's on the bottom?
Sine.
All right, Wilson, now I want you, not Beck, to go up here. Because look what, I've got a 1 minus a cosine squared. 1 minus that guy, so move him over would be equal to what?
Sine squared.
Perfect. It's sine squared on the top.
Over sine. Actually, 1 would cancel and it's sine.
Right.
God, it makes it so much easier when you write it.
I hear you. It is scary and overwhelming when you're on your own. But Graham, know that you're starting all of these right. You've started all of them right. When we've got multiplication, look for things to cancel out on the top and bottom. When we've got adding and subtracting, try to get those common denominators. Okay?
Yeah.
You can cross out 6 and 7. On 15, you guys, this one's just a challenge. I'm not going to put one like this on your test. But if you're up for a challenge, go for it. But you don't really have to worry about 15. Let's look at page 15. Let's do 14 together just to get your brains going. Then I'm going to give you the time to work on it. So, anyone have any idea? Which side would you prefer to work on? Left? To condense that down to equal that? Because if I worked on the right and I did -2 over cosine squared, I wouldn't know what else to do potentially. Actually, I am going to show you both ways. But if the left side is where your brain goes, let's try it. How would we get, if look at the answer, it has no fraction in it. We got to get rid of our fractions. So we could at least combine those 2 into 1. How would I do that? How do you add or subtract fractions? Common denominators. What does sine of y minus 1 need? Sine of y plus 1. You know it. Let's do it. Sine of y plus 1. What does the one on the right need then? You got it, guys. So we got, what do we have on top here? Sine of y plus 1 over
Sine squared.
sine squared Nice, because I'd have a minus sign, then I'd have a plus sign, and they're going to cancel out. Then I'd have minus 1. Then I'm going to bring down that minus sign. Yep, boom. And then I'm going to have a sine of y minus 1 on top.
Over sine squared minus 1.
And do we like that they match now? I like having some calm doms.
Absolutely.
This minus sign is why I want to do this problem together, because this is what's going to cause us problems. You guys, what would I have with my sine y minus sine y? Nothing. So I agree, those will cancel. Will it be a 1 minus negative 1 or 1 plus 1 or 1 minus 1?
1 plus.
Yeah, 1 minus the negative 1 would get me 1 plus 1. So what's on top?
2.
Does that make you feel pretty good that there's a 2 over here?
Yes.
I feel pretty good. I've got 2 over sine squared minus 1.
Minus 2.
What?
Oh, they're the same amount, my days.
Yeah. Good call. Because, and maybe you want to write this off to the side back that like 5/3 minus 1/3 is 4/3. That denominator doesn't change. You guys, what is sine squared? Minus 1. He knew it was going to be a negative. Do you guys agree? Because I got to bring that 1 over here, so I got to move the cosine to the right. So it would be a negative cosine down there. Negative cosine squared, right? You guys, I like that I got a negative because I needed a negative right here. Ooh, I'm dividing by cosine squared. That's the same as multiplying by, oops, I don't want to multiply. That is equivalent to what? Negative 2. Thanks, dude. Secant squared. And that's what I needed, and we did it. 12.
That 2, that comes out of the
Like we're the only Columbus.
You mean a squared?
Boys and girls.
Cosecant?
No, it's like an actual 2.
Okay.
Because it was 1 over 1 and they're adding, so it ended up 2.
Okay. Here's this potential strategy. Could we just do this? And rewrite that over that. Meaning I could say we got a cosecant squared over a secant squared plus, what's secant squared over secant squared?
1.
Boom. Okay.
So it's secant side of 2?
Could we rewrite that in terms of sine and cosine?
I thought this made sense better than
They're all
No, that's okay. Thank you, though.
So
Maybe. That's a good point.
the resource desk.
1 over sine squared divided by 1 over... Uh-huh. If you don't have this one done, I'll be writing it down.
I'm looking at it, yeah.
1 over sine squared times cos squared over.
Yeah, look at you with a cheat sheet. That's good. What is cosine squared over sine squared? Wait a minute. Why isn't this coming out? Because I needed cosecant squared. Sheesh, I left off my plus 1 this whole time. Thank you, J-Bro.
Thanks, Jim. You're
So I'd have cotangent squared plus a 1, which I'm going to go look at those shortcut Pythagorean identities. And what is cotangent squared plus 1? Cosecant squared. Okay, so on 15. What I want you to do, which side do you want to work on? Yeah, I agree. Let's go distribute. Whew. So that would get me
1 sine x minus cosine. And then you got, oh god.
You got it. Sine,
Sine squared x
love it.
times cosine
Uh-huh.
x minus sine x times cosine squared x.
Perfect. This is where the nuttiness happens. We need to turn these squareds into cubes, right? We have to, because there are cubes here. So what can I replace sine squared with?
You can't, oh, that's big, it's being multiplied.
Right, yeah. What can I replace sine squared with? Sine squared equals. Sine squared equals
Oh,
1.
1 minus.
Yes. I'm going to replace this sine squared with that because it's being multiplied by a cosine, and then I'll get a cosine cubed. Whew, I'm not going to expect you to do this. I'm going to bring this sign down. What can I replace cosine squared with?
It's gonna be 1 minus sine squared.
Perfect. And then when I distribute that back, I'm going to get a sine cubed there.
Yep.
So I replaced this guy with that.
Minus sine,
I'm going to bring that guy and that guy down. Sine minus cosine.
minus sine, plus sine.
I'm going to bring down my sine minus my cosine. And then I'm going to go distribute. And then life is pretty good, actually. We'd get cosine
It's cosine,
minus
cosine cubed.
cosine cubed, which I'm feeling pretty good about,
Yep. And then
minus sine plus
sine cubed.
sine cubed. I need this. Does anything cancel?
Yeah.
Sine minus sine, negative cosine. Oh yeah, and a positive cosine. I'm left with sine cubed minus cosine cubed.
Let's get it.
Whoo! That's nutty.